Good afternoon. Here's a presentation of about 15 minutes on the natural resources that drew many early settlers, including several Allen families that make up the Allen line of our ancestors, to the southwest part of Wisconsin in the 1820s and 30s. The ancestors are talked about in detail in Davis's presentation. I would like to talk about two things in this presentation. First, the origin and significance of the Driftless area, and second, the lead mines. The story begins with the glaciers that covered North America during most of the last 2 million years. The small inset map in the upper right shows that glaciers covered all of Canada, the upper parts of the U.S., and the entire area of the Great Lakes. They were present for almost 2 million years, retreating and finally melting about 10 to 14,000 years ago. On the main map, the white tongue-like features are the glaciers. Notice that during that period, the glaciers never advanced into southwest Wisconsin or the adjoining parts of Illinois, Minnesota, and Iowa. As a result, glacial deposits called drift don't exist there. Hence, the area is referred to as the Driftless area. It's believed that the movement of the glaciers into the Driftless area was inhibited from the north by the deep Lake Superior Basin just to the north of Wisconsin, and from the east by the high area of tough rock that made up the Baraboo Range, indicated as a number 2 on the map. This slide will, I hope, allow you to better appreciate the nature of glaciers. These are diagrams of several glaciers that exist today. In the top right is a diagram of the Continental Glacier that covers Antarctica and another of the one that covers Greenland. The cross-section in the upper right illustrates the size of the Antarctic ice sheet. Note the vertical and horizontal scales representing the width and thickness of that sheet. The glacier is vast, or glaciers are vast. They're about 5,000 kilometers across and on average about 3 to 4 kilometers thick. The weight of ice is also so great that the Antarctic landmass is depressed downward to below sea level in places. The picture in the lower right shows how the front of a glacier is typically covered with debris, mostly rocks and soil. Personally, I have even seen trees growing on the front of a glacier because the amount of dirt and soil that accumulates is so great. My point is that glaciers, especially ones 2 to 3 kilometers thick, scour the landscape, planing off the rock on the Earth's surface and leaving lots of rock debris when they melt. The basins holding the Great Lakes were carved by the scouring action of the glacial advances during the Ice Age. This also might give you a better appreciation of the power and abrasive force of the glaciers. The state geology map of Wisconsin shows the extent of glacial materials that exist today and were left behind when the ice sheets finally melted a few thousand years ago. The thickest deposits form ridges several hundred feet high at the front edge of the glaciers. These are called end or terminal moraines. They're shown on this map by the brown pattern. There's one there. Here's another set along the shore of Lake Michigan and others in northern Wisconsin. The Driftless area is the entire western and southwestern part of the state. It's free of glacial deposits except for some outwash material in the river valleys. The Driftless area is a term coined by T.C. Chamberlain, a world-renowned geologist, about 150 years ago, who first determined that large portions of North America were covered by vast, thick sheets of ice, and used evidence to prove that the climate was much colder and was the key reason the glaciers existed during the Ice Age. The topography and geography of the Driftless area is very different than the surrounding areas. It has relatively rugged topography with maximum elevations of about 900 feet above sea level in the south and almost 1,300 feet above sea level in the north. Its topographic relief varies locally between 100 to 300 feet, but some areas with as much as 1,100 feet of relief. In summary, the lack of any glaciers left a very rolling topography with a large variation in the maximum elevation. The geography of the Driftless area is such that much of the area was accessible by boat and barge in the early 1800s and railroads after the late 1860s. These were both economic forms of commercial transportation important for the early mining industry. The bedrock is a variety of rock types. Most importantly, consists of flat-lying sedimentary units overlying much older crystalline rock that forms the core of the entire North American continent. The overlying and younger sedimentary layers are mostly limestone and dolomite, with abundant fossils indicating they formed in tropical seas, much like now found near Bermuda. Throughout the driftless area, there are valuable deposits of lead and zinc ores in the shallow, flat-lying dolomitic rocks. The lead ores, called galena, and zinc ores, called blackjack or sphalerite, were easy to find in the shallow rock layers. If the driftless area had been modified by glaciers, it is very likely that these shallow rocks and mineral deposits would have been scraped, bulldozed away by the thick, powerful sheets of ice. This diagram is called a stratigraphic column. It is essentially a vertical illustration of the rocks found in the driftless area, arranged as they are in nature, with the rocks found at the surface at the top of the diagram, underlain in sequence by those below. The chart shows the formal names given to each of the distinctive rock layers, as well as thickness, a geologic description, and other important information. Most important to us on this chart shows in the first two columns on the left the relative abundance of the lead and zinc ores and the formations in which they occur. These black areas here. And here's the lead, the abundance of lead, and the abundance of zinc in the galena dolomite. The width of the black areas is proportional to the amounts of the lead and zinc in the galena. You can also see that the ores are found in other units as well, above and below the galena. Even so, the early miners focused only on the more useful and valuable galena. It was several decades before the zinc became important. The rocks hosting the ores were deposited between 450 and 470 million years ago, but the ores were emplaced in the galena formation more recently, probably about 300 million years ago, from brines migrating in bedrock from the south out of the Illinois basin. This map shows the area containing the lead and zinc mines within the driftless area of Wisconsin, Illinois, and very eastern Iowa. The decorated irregular gray line is the boundary that outlines the area where lead and zinc ores were found and mines were developed. The mines were mostly in Wisconsin, but extend down into Illinois a little south of the town of Galena and west to the far side of the Mississippi a little ways into Iowa. The principal business towns for the early mining industry were Galena, Illinois, and Shullsburg and Mineral Point, Wisconsin, and Dubuque, Iowa. These and others were established soon after U.S. citizens discovered and started mining in the late 18 teens and early 1820s. The U.S. government acquired ownership of the mineral lands in 1807 by an act of Congress. The blue coloring on this map shows actual locations and size of all the mines developed in the area between Shullsburg in the north, Galena in the south, and Dubuque in the west. Up until the 1950s, the mine workers were sporadically distributed and took work to find. The pioneer miners were successful in finding the ores by exploring and prospecting for the galena in the dirt, digging down into bedrock, and if lucky, finding a vein or chute in fractures and or bedding surfaces in the bedrock. In the 20th century, more sophisticated methods were developed and used to find the ores. These two sets of diagrams show the typical nature of the ore bodies. The top two diagrams show map, view, and cross-section of ores found in vertical fractures. The bottom two diagrams show map and cross-section of ores concentrated in horizontal beds. It was common that ore deposits of both types were found at one mine. The earliest mines were very near the land surface and referred to as diggins. Pick and shovel were the typical tools in those early days. Later, deeper and larger mines were developed using shafts and tunnels and needed more sophisticated equipment like muckers, ore cars, drills, explosives, and water pumps. This illustration shows a mine operation in the 1800s. At bottom center is shown the dark round opening to a vertical shaft, which allows access down into the mine with a manually operated winch to lift workers, supplies, ore, and waste in and out of the mine. Later, the lifts were powered by steam, then electricity or diesel and gas engines. Early on, the lead was liberated from the galena ore by roasting in a fire or furnace, which drove off the sulfur and left a puddle of impure lead behind. The Scotch hearth type furnace shown in the background of the illustration is similar to the first Scotch hearth possibly built in the U.S. near Platteville. Lead mining in the Driftless area started with the French explorers about 1695. Indigenous people did not have a use for the lead metal, but they did mine the ore, which they sold to the early explorers and later settlers. First real mine and smelter were developed in the area where Dubuque, Iowa is now located, and operated from 1788 until 1810. The first more permanent mining camps were established in 1824 in Hardscrabble, now known as Hazel Green, Wisconsin, and New Diggings, Wisconsin. Shown in this chart is the production of metallic lead in thousands of tons by year from about 1800 until 1952 from the mines in the Driftless area. Notice the steep increase in production starting in the early 1820s after American settlement in the area. Lead production peaked at about 27,000 tons per year in the mid-1840s. After that, production dropped as demand decreased and or other mines opened elsewhere to meet the demand. But more significantly, miners left Wisconsin for California as part of the short-lived gold rush of 1849. This chart shows the production of zinc metal from the same mines and for the same period. Peak zinc production occurred during World War I and fluctuated after that until the mines closed in the late 1970s due to economic and business factors. After the lead and zinc mines closed, much effort and money was spent by state and federal agencies to clean up lead, zinc, and other associated metals that contaminated the soil, bedrock, and groundwater in the mining areas. On the left is galena, the main ore for lead, and on the right is sphalerite, the main ore for zinc. Lead was in demand for a variety of uses because of its low melting point, as well as being soft, heavy, ductile, and had other properties that made it important for making pewter, pipes, ceramic glazes, paint, munitions, bullets, and later batteries and as a gasoline additive. Zinc is an important metal used as a rust inhibitor, plating iron and steel objects, a process called galvanization. It was also used for castings and as an additive for paint, rubber, and sunscreen. It is also a key ingredient with copper to make brass, used in household items, plumbing, automobiles, and boat and shipbuilding. This is David Dale Owen, a prominent American geologist who in 1839 conducted the first scientific survey and first mapped the lead and zinc deposits in the Driftless area. He was born in Scotland, raised in Indiana, where his father, Robert Owen, had attempted to establish a social living experiment at the town of New Harmony. The fact is of interest to our family because our grandfather, Rodney Brandon, his grandfather, was involved and influenced by the mission and ideas of New Harmony. It's amazing that the two branches of our family, Nancy and Jack's, somehow overlap many generations before they met. I'd like to conclude by summarizing. The Driftless area was a very attractive part of the new frontier territory in America that drew settlers in the 1820s because of the easy bounty of lead and later zinc. Because the Driftless area was not glaciated, the shallow bedrock formations that held the lead and zinc ores were still present to be found and developed, leading to an economic boom that drew many settlers, including our ancestors, the Brewster, McNultys, and Williams family. This concludes my presentation. Thank you.